Question number 5. Question number 5 says, differentiate the expression 1 plus 2x all cubed times x plus 3 with respect to x and simplify your answer. So differentiate the following expression with respect to x and simplify your answer. So I don't like to just differentiate like that. I'm going to call the expression y. I like to call it y. It feels better to me. All right. So 1 plus x cubed times x plus 3. I'm calling it y. You don't even have to call it y. All right. You can call it something else. Let's call it something else. Let's say let's call it v. All right. You don't have to call it y. So this is v. Then dv by dx is going to be equal to, we're going to use product rule. Within product rule, it's going to become, keep the first one, which is 1 plus 2x raised to the third power times the differentiation of the second, or the derivative of the second, which is 1. You differentiate x plus 3, get 1, plus keep the second one, which is x plus 3, times the derivative of the first one. And the derivative of the first one is carry down the power 3, subtract 1 from the power to get 1 plus 2x, subtract 1 from the power to get square, and this is of course then multiplied by 2. Instead of multiplying it by 2, I'm just going to change the 3 to 6. Nice and easy. This is what we have. So what we're getting then is dv dx. So we're getting dv dx is equal to 1 plus 2x cubed plus 1 plus, well, I can put the x out first. So I can say plus 6 times x plus 3 times 1 plus 2x all square. Nice and easy. This is what we have. And this is dv dx. So in reality, what this is going to work out to be then is, we can factor out 1 plus 2x squared. Factoring out 1 plus 2x squared, we're going to be left back with, in this bracket, this is if you just want to factor out 1 plus 2x squared, because it says simplify your answer. So factor out 1 plus 2x squared, you're going to left back with 1 plus 2x times 6x plus 18. So let me see if I can add them mentally here. We're going to have 1 plus 2x, and then the 2x plus 6x is 8x. And 6 times 3 is 18. 18 plus 1 is 19. So this works out to be 1 plus 2x all squared times 8x plus 19. That's how you simplify that. Now part B. Part B says the point P lies on the curve minus 2, 0. And it says determine the equation of the normal at the point P. So before we can find the equation of the normal, we need to find dy by dx to get the gradient of the tangent. So dy by dx is going to equal to, we differentiate 3x squared to get 9x squared, plus when we differentiate 2x squared, we get 4x, and then we subtract 24. But when we get dy by dx, this is the gradient function for the gradient of the curve. But we don't want the gradient function for the gradient of the curve. So all we need to do now is plug in the gradient of the tangent. When we plug in t equal -2, not t, x equal -2, that will give us the gradient of the tangent. So 9 times -2 squared plus 4 times -2 minus 24. That will give us the gradient of the tangent. So when you put in all of this, the gradient of the tangent works out to be, let's calculate this, 9 times -2 squared plus 4 times -2 minus 24, that's 4. That's the gradient of the tangent, 4. Since the gradient of the tangent is 4, then the gradient of the normal is -1/4. That's the gradient of the normal, -1/4. Now that the gradient of the normal is -1/4, the equation of the normal, I'm going to call it EQ. This means equation. So the equation of the normal is y minus 0 is equal to the gradient of the normal, which is -1/4, into x minus 2, x minus -2, which is x plus 2. You can simplify it if you want. They didn't say to put it in standard form. They just find the equation of the normal. This is it. I don't need to put it in standard form. They really didn't ask me to do that. So I'll stop right there. Part C. Part C says water is poured into a cylindrical container where the radius r is 15. So that's the first thing I want to write down, r equal 15. And they say that the height of the water increases at a rate of 2 centimeters per second. That's the next thing they give us, the height increases, so that's rate, dh by dt. And they say the height increases at a rate of 2 centimeters per second. So dh by dt, which is equal to 2. And it says, given that the formula for the volume of the cylinder is pi r square h. So given that the formula for the volume of the cylinder, so this is the next thing they give us, volume is equal to pi r square h. Then they say determine the rate of increase of the volume of the water. So they want us to find the rate of increase of the volume of the water in the container. So they want us to find dV by dt. Now, dV by dt is going to be equal to dV by dH times dH dt. This is known as connected rates of change. So it's dV by dH times dH dt. All right, that's dV by dt. Now, dV by dH means to differentiate V in terms of H. So dV by dH will be carried on, well, differentiate pi r square H. I'll just get pi r square. So just get pi r square. Because think of this as a constant. So when you differentiate pi r square H, dV by dH is pi r square. And then that's multiplied by 2. So that means that dV by dt is 2 pi r square. But then what is r? R is 15, so it's 2 pi times 15 square. 15 square, I think that's 225, times 2, that's 450. And so dV by dt is 450 pi. dV by dt is 450 pi. All right, and then remember volume is in cm cube. So it's 450 pi cm cube per second. That's dV by dt. Nice and easy, soft. And they're giving away 5 marks for that. Nice. Question 6. Question 6 is generally integration. And generally when you're doing integration, you don't really have nothing to worry about. You're just integrating. All right. Well, you don't have nothing to worry about with none of these questions, but we're just saying. So it says, show that the integral from 0 to pi by 4 of sine x plus 4 cos x is 3 root 2 plus 2 over 2. So let's go ahead and integrate. Now when you integrate sine x, you get minus cos x. Then when you integrate cos, you get sine. So you get plus 4 sine x. And of course, you're integrating from 0 to pi by 4. So we're integrating from 0 to pi over 4. Now that we're integrating from 0 to pi by 4, first thing you need to do is plug in pi by 4. So plug in pi by 4 in here, and so you get the cos of pi by 4, which is the cos of 45, and the cos of 45 is what? Cos of pi by 4, that's root 2 over 2. So when I put in that, I get minus root 2 over 2. Then I put in sine pi by 4, which is plus 4 times root 2 over 2. 4 times root 2 over 2. That's the sine of pi by 4. Minus, now I need to put in now 0. The cos of 0 is 1. So I get minus 1 plus the sine of 0 is 0. All right, so this is what we have now. This works out now to be minus root 2 plus 4 root 2 over 2. Now 4 root 2 over 2 minus root 2 over 2 is 3 root 2 over 2. Yep, that's 3 root 2 over 2. Just want to make sure. 3 root 2 over 2. And then minus and minus become plus. So that becomes plus 1. Now, plus 1, you can always change 1 to. So we can rewrite this out as 3 root 2 over 2 plus 1 can be written as 2 over 2. That's how we can write 1. 1 can be written as 2 over 2. And so what we get then is 3 root 2 over 2 plus 2. 3 root 2 over 2 plus 2 divided by 2. That's it. It's question number 6. Soft. Nice and easy. Now the next part of the question, part B, says determine the equation of the curve whose gradient function dy by dx is x plus 2. So determine the equation of the curve whose gradient function dy by dx is x plus 2, and it passes through the point P, which is 2, 3. So let's go ahead and do this to differentiate the equation of the curve. To determine the equation of the curve, y is equal to the integral of dy by dx, and so y is going to be equal to the integral of x plus 2. Y is equal to the integral of x plus 2 dx. When we integrate x plus 2 dx, what we're getting is, when we integrate this, we get x squared over 2 plus 2x plus some constant of integration, maybe call it c. This is y. All right, this is y. Now, given that y is equal to x squared over 2 plus 2x plus c, this is y. All right. Now, it gives us at the point 2, 3. So y is equal to 3 when x is 2. So when y is 3, 2 squared is 4. 4 over 2 is 2. Plus 2 times 2 is 4 plus c. So we have 6 plus c is 3, and so c must equal to negative 3. If c is negative 3, then the equation of the curve is y is equal to x squared over 2. Y is x squared over 2 plus 2x minus 3. That's the equation of the curve. X squared over 2 plus 2x minus 3. That's the equation of the curve. Nice and easy, soft. Last part of this integration question, and it says calculate the integral of 4 minus x squared from 1 to 2. Now there are two ways to do this. My method, this is just how I like to do it. I like to expand. I like to write this as integral from 1 to 2 of expanding this, I get 16 minus 8x plus x squared. I like to expand like that. Dx. And then I can go ahead and integrate. When I integrate, I'm going to get 16x minus 8x squared over 2 plus x cubed over 3. And I'm integrating from 1 to 2. This is how I prefer to do it. I really like to expand brackets. Whether it's square, cube, I just like to expand out the bracket from 1 to 2. Then we can substitute in x as 2. And we get, when you plug in 2, you're going to get 16 times 2 minus 4 times 2 squared plus 2 cubed divided by 3. And I'm getting 56 over 3. And I plug in 2, I get 56 over 3. Minus, when you plug in 1 now, when you plug in 1, you're going to get 16 times 1 minus 4 times 1 squared plus 1 over 3. And I'm subtracting, that looks like 37 over 3. So 56 minus 37 over 3. That works out to be 56 minus 37 is 19. This works out to be 19 over 3. Now let's call this I. Call this integration I, right? So this is method 1. Method 2, this is the method that most people will take. You're going to say that I is of course equal to, you add 1 to the power to get 4 minus x all cube, and then you divide it by -1. This is the common approach that most people will do, and you're integrating, of course, from 1 to 2. This is a common approach most people will take. And then you plug in the 2 and you get 4 minus 2, and you get 4 minus 2. Add 1 to the power, divide by the power. I forgot to divide by the power of 3. Put the 3 in here. Divide by the differential in the bracket, yeah. Then people put in the 2. 4 minus 2 is, that's 2 cubed. So you get 2 cubed over -3 minus, put in 1 now, you get 4 minus 1 is 3. And so you get minus 3 cubed over -3. Most people will do it like this, and you should get the same answer, because you're going to get 2 cubed divided by minus 3 minus 3 cubed over minus 3 . Let's go again. Add 1 to the power, divide by the power, divide by the differential. We put in 2, 4 minus 2. 4 minus 2 is 2. 2 cubed. 2 cubed is 8. So that becomes 8 divided by minus 3. Minus 3 cubed over minus 3. 3 cubed is 9. 3 cubed is 27. 27 over minus 3. 27 over minus 3. And you get the same answer, 19 over 3. So it depends which way you prefer to do it. I prefer to do it the first way, but it's up to you, your choice. Right? It's all your choice. Now, part D. Part D says calculate the volume of the solid when the area by the straight line y equal x over 2 and the x-axis for x being equal to 0 to x equal 6 is rotated through 2 pi about the x-axis. Now, volume about the x-axis is equal to pi times the integral from a to b. In this case, it's the integral from 0 to 6 of y squared. Y squared is going to be x squared over 4 dx. That's volume. So the volume will be equal to pi times the integral of, add 1 to the power to get x cubed, divide by the power 3, but 3 times 4 is 12. And we're going from 0 to 6. We don't even need to put in the 0. We just need to put in the 6. Put in the 6 and we get 6 cubed over 12 is 18. So the volume is equal to 18 pi. Volume is 18 pi. And remember, volume is in units cube. So that's the volume, 18 pi units cube. Nice and easy. Soft. So that's the volume. Question 7. Now, we finally reached to section 4. Now, when you get to section 4, you're only required to do one question. You don't